Okay, I've kind of taken some liberties on my presentation. Basically what I've done is I've listened to the presentations here at the forum so far, and I've heard a lot of discussions about technology, analytics in particular, etc. And I decided the best way to communicate a framing of the topic is to use my own words and put it in terms of what it means to me, how I understand the topic. I hope that goes over well, and I hope you enjoy it. Okay, you can see by the title that I've taken a little bit of liberty here. Eventually, what you don't know is going to jump up and bite you in the tail, and that's what we're talking about. The quotation that I've got at the bottom is very significant to me, and where that comes from is the Bailey Lobby, which is now owned by ABB out in Wycliffe. And what that statement there means to me is, and let me get into a little bit, Lord Kelvin says that if you can measure something and put it in an equation form, you know something about it. If you can't do that, your knowledge is meager and not worth a lot. I would say that he could be talking about the topic that we're going to present right here. And what that means is we have part of the problem known to us and part of the problem unknown to us in terms of data and how it behaves. The part that is known to us we do well with because we can write equations and transfer functions which describe it and know how to control it. We do a good job at that. The part that's unknown, we don't do a good job in, and that's an area that we have the opportunity for improvement. And I would say that was what Lord Kelvin would say to us right now. As I was just saying, not knowing what you don't know can add cost and risk. We all have to understand that. Some considerations. Okay, process industry is a very complex manufacturing involving millions of complex compounds and millions and tens of millions of different relationships. That is particularly true in the hydrocarbon industries where we're processing hydrocarbon feedstocks. We only really know a fraction of all the relationships and the behavior out there. The question is, we don't need to know everything because not everything is critically important, but some of it is and some of it's dangerous. What is and what isn't? The other consideration we have to have is that understanding or knowing is a function of our knowledge. We're faced with a very critical situation in terms of knowledge where our knowledge going forward is going to be diminishing because a lot of the experienced people that we have in process manufacturing are leaving. We have a situation that in terms of formal learning on how process manufacturing works, colleges do not do a good job. We all realize that. As I've mentioned, experience is leaving, and as a consequence, the intuition that's needed by operators and operating personnel to understand how the process is going to behave is available only now on a limited basis. And as you can see, in terms of the corporate knowledge resources, the employees' brains are the biggest part of it, and that's where we're going to have our greatest losses. Okay, 3 issues, and these are actually, I should have said 3 benefits here. I see the benefits coming in 3 areas. The first area is having more people make more correct decisions. That's also a definition of operational excellence. The second one is, and let me step back a second. I would say that the opportunity we're faced with right here is somewhere between 15 and 20% of nameplate production, nameplate quality, etc. 15 to 20%. The biggest part of it is with more people making more of the correct decisions. That's probably in the range of 10 to 12%. The next one is the people being able to, or machines being able to anticipate general incidents and proactively react to avoid them or minimize the consequences associated with them. That's about a 4 or 5% opportunity. The last one there is being able to understand the root causes so you can minimize the impact of these events and also eliminate them as a possibility in an event in the future. That is a smaller number. But I think we're looking at about a 15 to 20% of nameplate opportunity here. I'm going to talk about each of these individually. In terms of people making more of the correct decisions, the thing that needs to be changed is that people need to be empowered by a production cycle perspective as opposed to a real-time perspective. We also need to be able to collaborate much broadly in real time with exacting information that's very fresh. In the past, we focused on real-time performance management. I would say that is important, and we should keep one eye on that. But at the same time, we need to keep another eye on the production cycle performance. And what I mean by that is, at the trajectory that you're moving right now, are you going to be able to satisfy your product requirements at the end of the production cycle? And are you going to be able to take into account abnormal situations through the remainder of the production cycle to be able to guarantee that you're going to be able to satisfy what your requirements are? In terms of collaboration, the value of collaboration is measured in two ways. The breadth of the collaboration and when you can deliver that collaborative information to the right people. A very major contribution. The next item is being able to anticipate general incidents and proactively react to those. Right now, on a worldwide basis, in process manufacturing, 2 to 5% of production is lost to unscheduled slowdowns and shutdowns. We need to utilize statistical analysis to identify these abnormal conditions, and we need to be able to use predictive modeling to be able to give us the production cycle perspective that we need to operate at top levels. Okay, if we look a little bit at the technology, and I would present this as a generic approach, not necessarily consistent with our two speakers, but basically what we're doing here is taking a normal operating model, a view of the operation run over its operating ranges, utilize first-level statistical analysis to determine the behavior of those elements. Then secondly, use a second level of statistical analysis along with predictive modeling to determine the exact root causes of the problem, so we're in a position to be able to eliminate that cause, react to it so we can minimize any impact, and also take corrective action in the future. There's two ways I would suggest that you can look at this. This is a typical layers of protection model that we've talked about many times. I would suggest to you that we're adding another layer of protection, which is incident prediction, where an operator has the opportunity to see an event that's going to happen where he has no other indication that will happen, a fault. Secondly, I would suggest that we look at this in terms of a level of alarming which helps us suppress the severity of the consequences we're dealing with. Historically, in the past, we've seen an event detection, which is an alarm on the console, a decision on what needs to be done, and then an action is taken. As you can see, the severity of the consequences are moving up fairly rapidly through that range. What we'd like to see happen is a proactive approach where the diagnostics and decision-making is made well in advance, and the action is taken at a point where severity is much lower, and through time we can drive the severity even lower. And the last item is determine the specific underlying causes. We need to utilize functional decomposition to define the logical relationships. It identifies specific causes as a result of certain faults. Be able to operate and correct those. Look at alternate operations to an impending accident, so either we can avoid the incident or minimize its consequences. And then finally, be able to look at systematic problems in the process so we can eliminate those from future requirements, and makes everything better. Okay, thank you.